Okay, now we will discuss one more very important problem which is based on the riveted joint. Now you can see here, first let us understand the given problem. A double riveted butt joint with two cover plates. A double riveted butt joint with two cover plates for a longitudinal seam boiler. Okay, for a longitudinal seam of a boiler shell 1.5 meter in diameter subjected to a steam pressure of 0.95 Newton per mm square. Assume the efficiency of 75% allowable tensile stress in the plate is 90 Newton per mm square and the allowable crushing is 140 Newton per mm square and allowable shear stress of the rivet is 56 Newton per mm square. Okay, this is a given problem. Now let us note down the data. Now you can see here the di is equal to 1.5 meter. Okay, 1.5 meter, that is equal to 1500 mm, and okay, the pitch, that pressure which is 0.95 Newton per mm square, 95 Newton per mm square, and the efficiency is equal to 75%. Efficiency is equal to 75%, and sigma theta is equal to 90 Newton per mm square, which is given in the problem. Allowable, okay, the tensile stress crushing sigma c is equal to 140 Newton per mm square, and tau is equal to 56 Newton per mm square. Okay, this is the given data. Next, what we need to do, we need to select the type of joint. Next, type of joint and sketch. Type of joint and sketch. So here assume two equal cover plates. So they will not mention anything regarding the equal or unequal. Here assume two equal cover plates from table 13.14. So here type G joint. Okay, type G joint is selected. So here for chain type, okay, for chain type rivet, I1 is equal to 0. It is a butt joint, okay, not lap joint. So I2 is equal to 2. Okay, so this is about the given data which is subjected to the given problem. Next, okay, for this is a figure I have copied from the design data handbook from the table number 13.14. Okay, this is a given figure. Okay, next, how to find out that thickness of the plate. Here we need to find out the thickness of main plate. Thickness of the main plate. So we know the equation. So H is equal to Pt di divided by 2 neta sigma theta plus C, where C is the clearance or allowable for correction, that is equal to 1 mm. If you substitute all the values into this equation, so H is equal to 0.95, that pressure, into diameter 1500 mm divided by 2 into the percentage they have given in the problem, which is 0.75, into that sigma theta is equal to 90 plus C is equal to 1 mm. So if you simplify this, H is equal to, will get 11.55 mm. So we will round up this value to H is equal to 12 mm. Next, what we need to find out? We need to find out the diameter of the rivet and rivet hole, diameter of the rivet as well as the rivet hole we need to find out. So, equation D is equal to 6 root h to 6.3 root h. If you substitute that value 6 root 12 to 6.3 root 12, if you simplify this, you will get diameter is equal to D is equal to 20.785 to 21.824 mm. Okay, so from table 13.2, from table 13.2, the standard diameter, the standard dia of rivet is equal to 22 mm. So, for that the standard dia of rivet hole is equal to 23 mm. I will show you that in the video. Okay, so in that video I have already shown that how to take the value of the diameter, okay, the standard diameter. Okay, next the diameter of the rivet is equal to 22 mm. Okay, next what we need to find out? We need to find out the pitch called P. We know the equation which is available in the design data handbook. P is equal to 1.875 I2 plus I1 into pi d square tau divided by 4h sigma theta plus d. Okay, so this is the equation which is available in the design data handbook 13.30. From the design data handbook we will get the equations. So, if you simplify this, we will get 1.875 into I2 here, which is subjected to butt joint with a given problem. I2 is equal to 2 plus I1 is equal to 0 into pi d, which is 23 square into 56, okay, divided by 4 into 12 into 90. Okay, so sigma theta is equal to 90 plus 23. So, if we simplify this equation, we will get pitch is equal to 103.787 mm. Also, we need to find out the pitch from the table, from table 13.14, from table 13.14. So, we need to find out the pitch for the selected joint. P is equal to 3.5 h plus 40. If you substitute the values into this equation, 3.5 into h, how much? 40 plus 40. So, P is equal to, you will get P is equal to 82 mm. So, here we need to consider the minimum value. So, this is the minimum value. So, we need to consider this value for this given problem. Next, what we need to find out? We need to find out the next parameter. We need to find out the transverse pitch. The transverse pitch in the sense the PT. We need to transverse pitch. We need to find out the transverse pitch. Transverse pitch P suffix T with respect to this given problem. Fifth parameter. So, from table 13.11 for the P by D ratio, for the from the table 13.11 from the P by D ratio, I will show you the table number 13.11. Okay, this is the table number 13.11, okay, for the transverse pitch. So, this is a P by D ratio. So, here we know the pitch, that is 82, or okay, the pitch is 82 divided by the diameter is 23. So, if you simplify this, we will get 3.565 mm. So, further with respect to this value, here we know that P by D is equal to, so we'll get in between 3 and 4. Okay, so for that, so PT value should be 2D. So PT value should be 2D. So where PT is equal to 2D, so if you substitute that value 2 into 23, so we'll get, okay, 46 mm. This is the transverse pitch. Also from table 13.14 for the selected joint, okay, PT is equal to 2D. So same thing, 2 into 23, PT will get 46 mm. So here whatever the value it may be, so always you need to select the greater value. So here select greater value, okay, in transverse pitch. Next, what we need to find out? We need to find out the margin. Margin we need to find out. So what is the equation? M is equal to 1.5 times of D. M is equal to 1.5 times of D. So if we substitute that value 1.5 into 23, so we will get 34.5 mm. M is equal to 34.5 mm. 34.5 mm. Next, okay, what we need to find out? We need to find out the length of the shank. Length of the shank we need to find out. So here for double riveted, okay, for double riveted cover butt joint, double riveted cover butt joint, L is equal to H1 plus H plus H2 plus 1.5 D to 1.7 D. Okay, so if you substitute all the values into this equation, L is equal to, we know the H1, so 7.5 plus, which is the H is equal to 15 mm, so 7.5 plus 12, sorry, 7.5 plus 12 plus 7.5 into 1.5 into 23. If you substitute, if you simplify this value, you will get H is equal to 61.5 mm. 61.5 mm. Okay, this is a value for the length of the shank. So from table 13.13 for diameter D is equal to 23 or 22. So diameter of the rivet, I am talking about diameter of the rivet, 22 mm. So preferable length or preferred length L is equal to 63 mm. L is equal to 63 mm. I have already shown in the last class how to find out the preferable length, okay, with subjected to the problem. Next, what we need to find out? We need to find out the length of the shank. We need to find out the length of the, so we already find out the length of the shank, and we need to find out the width of the cover plates. Width of the cover plates, so W is equal to what is the equation? So 4m plus 2 pt, 4m plus 2 pt, which is available in the design data handbook, that is 13.19a, which is available in the design data handbook. Now if you substitute that 4 into the margin, so margin is equal to 34.5 plus 2 into pt, so transverse pitch, so 46 mm. So if you simplify that, W is equal to how much we'll get? W is equal to, so 230 mm. 230 mm we will get. W is equal to 230 mm we will get. Okay, now what we need to find out? We need to find out the strength of the solid plate. Strength of the solid plate. Strength of the solid plate. So here, how to find out the strength of the solid plate? We know that equation, F theta is equal to PH sigma theta, that is equation number 13.20, which is available in the design data handbook. If you substitute all the values into this equation, so P is equal to 82, H is equal to 12 into 90, sigma theta is equal to 90. If you simplify this, we will get 88560 newtons, 88560 Newton. This is called an F theta, strength of the solid plate. Now what we need to find out? We need to find out the least strength. Least strength. How to find out the least strength? So here we have three cases. The perforated length, preferred plate, that is equal to P minus D into H sigma theta. Substitute all the values which is available in the design data handbook 13.21 equation. So if you substitute that, 82 minus 23, for all strength calculations we need to consider the diameter of the rivet, into 12 into sigma theta is equal to 90. If you simplify this, you will get 63,720 newtons. 63,720 newtons. Next, what we need to find out? In second case, we need to find out F tau. So F tau with respect to shear stress, 1.875 I2 plus I1 into pi d square divided by 4 into tau. Okay, so this is also available in the design data handbook 13.22. Okay, if you simplify this, substitute all the values into this equation, 1.75 I2 is equal to 0, sorry, I2 is equal to 2 with respect to this butt joint, I1 is equal to 0 into pi d square 23 square divided by 4 into tau 60. If you simplify this value, F tau will get 87249.88 newtons. This is a value we will get it. This is the value we will get it. Next, what we need to find out? We need to find out the value of, okay, the value of this one, the crushing, okay, which subjected to crushing strength, Fc we need to find out. Fc is equal to, third case, Fc is equal to I2 H plus I1 H2 into d sigma c. So this is available in the design data handbook. Substitute all the values, 2 into 12 plus 0 into 12 d. Here H1, H is equal to H2. Okay, so if you substitute all the values into 23 into 140, if you simplify here, if you simplify this equation, Fc is equal to 63720 newtons. 63720 newtons. 63720 newtons. Next, what we need to find out? We need to find out the efficiency. Efficiency is equal to, neta is equal to the least strength. Least strength to the strength of the, least strength to the strength of the solid plate, length of the solid plate. Okay, now if we substitute the values, we know the least strength. So from the strength of the solid plate, okay, least strength which we will get from this okay problem, 63720. This is the least strength compared to tensile, crushing and shear. So for that, crushing strength is the least strength with respect to this problem, divided by maximum strength, that is 88560. 88,560. If you simplify this, efficiency is equal to 0.7192. Okay, that is equal to 72%. Okay, 72%. Since since the since this efficiency is nearer to the given value of 75%, the design is safe. Okay, so this is the efficiency. Okay, this is then the design is safe. Okay, this is about the given problem.